Hello everyone, welcome back to another very challenging, interesting question from System of Particle taken from Pathfinder right in front of me. I will be reading from here. So let's get into it. First let me read the question first, and after that we will discuss about how to solve it. A hemispherical bowl is placed on a frictionless horizontal floor. So this is a frictionless horizontal floor we have, this is what I have, okay, and then we have hemispherical bowl there, very good. And it is placed on and again they said frictionless surface, that is also very important point. The disc and the bowl are of equal mass. So equal mass will make the equation simplified a little bit, okay, fine, and there is no friction between them as well, very good. The disc is slightly pushed horizontally. Slightly pushed does not mean that you are throwing it, slightly just disturbing it from there, so that it starts sliding down the bowl with negligible speed. So initial speed is 0, we can take it. At what angular displacement of the disc measured from the vertical line? So if you take this as a vertical line, from that vertical line at what angle it is going to lose contact, that is what he is asking about. Okay, very good. So let us try to understand the concepts, the ideas that we need to use here. Number one, I will use the relative velocity concept. When two bodies are touching each other and they are having a rigid interface, then we can always use wedge constraint there. Wedge constraint is something that we can always use. So wedge constraint says that the relative velocity has to be tangential to the surface. So that is what I had mentioned here. You can see that relative velocity is tangential to the surface. This is relative velocity VR, tangential to the surface at any particular angle. Let me pull it up there. Okay. And if I know the relative velocity, you add the reference velocity so that you get the resultant velocity. The resultant velocity of the disc equal to relative velocity plus bowl velocity, together is going to be relative velocity, vectorial addition. I am assuming that bowl has a velocity v left side, because there will be a normal reaction over here pushing it to the right, left side there. So v added to Vr vectorially, you will get the total velocity of the disc in ground frame. And let me see, this is the angle theta, for example. Let us say that is what they are asking you to find, this theta. If the normal makes an angle theta with vertical, the tangent, corresponding tangent makes an angle with horizontal, same theta. So this is going to be theta with horizontal, okay, alright. So that means this is theta, that means this angle is going to be pi minus theta. I think that is what I had written here. Angle between Vr and V is 180 minus theta. Once I have that, I can use vectorial addition root over a square plus b square plus 2ab cos theta, where theta is 180 minus theta. So you get net velocity, okay. So I need to know Vr, V and so on. If I require, I do not require actually net velocity, we need to find theta there, cos theta, theta value we need to find. Okay, what else can we use? I can use conservation of mechanical energy. See, please remember, whenever you have complicated problem, do not directly go into Newton's laws, it becomes complicated in terms of mathematics, integration and all. Try to use conservation principle as much as possible. If conservation principles are not enough or not valid, then you are forced to go with Newton's law, then integration you have to go with it. As much as possible, go for conservation of principles, mechanical energy, linear momentum, angular momentum. So first of all, can we use conservation of mechanical energy? Yes, the reason is the surfaces are frictionless. So no dissipation of mechanical energy, definitely I can use conservation of mechanical energy. I write it as COME, come. And here the disc is going to lose gravitational potential energy, mgr into 1 minus cos theta. 1 minus cos theta is the standard result. And loss in gravitational potential energy will be converted into gain in kinetic energy of both the bodies. Not only the disc, even the bowl would move towards left. So the first term half mv square is the velocity of the bowl, kinetic energy of the bowl. The second term, that big expression, is going to be kinetic energy of the disc, because you have got two velocity vectors to be added vectorially. Okay, so conservation of mechanical energy we have used, equation 1. The next one what you can use is conservation of linear momentum. Of course, in vertical direction we cannot use conservation of linear momentum, because there are external forces, gravity is there and normal reaction from the floor is also there, they are not balanced. Center of mass is going to go down, it will have some vertical acceleration. So I can't use conservation of linear momentum vertically, but definitely I can use along horizontal direction. The bowl has m into v left side momentum, m into v is the momentum of the bowl, and that should be equal to momentum of the disc in horizontal direction towards right, because net horizontal is 0, initially 0, always 0. So, but if you look at the ball, it has got two velocities. I resolve VR along horizontal direction, you get VR cos theta, trying to pull it right side, and you need to add V vectorially. So, the resultant velocity will be VR cos theta minus V. So, m into VR cos theta minus V is the momentum of the disc horizontally towards right, which is counterbalancing m into V of that ball in the left direction. Simplify it, you get the second equation. So, now you count the number of unknowns here. You have V, VR, theta, 3 unknowns we have, and we got 2 equations from these conservation principles. Then if you go back again, they were talking about losing contact. You see, losing contact, we have to use that condition. No? So, definitely you should know what is a mathematical equation to say that it is losing contact. This is normal reaction between the disc and the ball at that instant has to be 0. I am sure you are aware of this relation, n equals to 0. So, if n equal to 0, then acceleration of the ball would be 0 horizontally. There is no other force acting on it horizontally, only n sin theta would be there. So, that means once it becomes having 0 acceleration, I can say that ball would be inertial frame at that moment. Before that it will have acceleration, after that also, of course after that it will leave contact, after that also it is going to have 0 acceleration. Up to that moment it was having acceleration, but at that moment it has got 0 acceleration. So, because it has got 0 acceleration, I can say that ball is a inertial frame. So, what is the use of inertial frame? Whenever you have inertial frame, you can use Newton's law directly without applying any pseudo force and all. So, that is the idea here. So, I can use pseudo force. With respect to ball, I observe. With respect to ball, you would see only relative velocity tangential to the surface, that is wedge constant, we got it. And what are the other forces acting on it? Anyway, we have no normal reaction here, only gravity was there. Gravitational force component towards the center is supposed to produce centripetal acceleration. So, centripetal force here on the disc would be m into that is mg into cos theta, and that has to be providing centripetal acceleration. So, mg cos theta equal to me square by r. From there I get Vr equal to rg cos theta. So, now we have 3 equations. You go back up. First equation comes from conservation of mechanical energy, second equation comes from conservation of linear momentum horizontally, third equation comes from the idea that it is losing contact at that moment, normal reaction 0, and so centripetal acceleration with respect to the ball is provided only by gravity. Now it is about solving them. First what you do is take second and third equations, second equation and third equation, and then little bit solving it, you will get V and VR relation. Already VR we got now from the third equation, you can substitute there, you get this. This is going to be V. So, V is there, VR is there. Now we go to equation 1 and substitute these two equations there to get the calculations of cos theta. So, 2gr into 1 minus cos theta is the loss in gravitational potential energy head there, multiplying with 2 there, and the other side you will have kinetic energy terms. So, now if you substitute V and VR there, I am getting a cubic equation there. So, 2 equals to 3 cos theta minus 3 cos cube theta. So, you can have a look at this relation, pause and then try to solve it. See, primarily getting those 3 equations important, simplification I am sure you will be able to do better. Now, I bring everything here, I have to find a solution to this cubic equation. I would get cos theta equal to root 3 minus 1, I will prove it how it is. I will just take it, let x equal to cos theta. So, the equation becomes x cube minus 6x minus 4. What I would do is that minus 6x I will write as minus 4x and minus 2x, and then you know how to solve it from there. You take x common here, x squared minus 4 minus 2 into x minus 2 equals to 0. Then further x square minus 4 you can write as x plus 2 into x minus 2. Now you got x minus 2 common. I take x minus 2 common, you will get this term there. So, the solution to this would be either x minus 2 has to be 0 or this quadratic equation has to be 0. So, x minus 2 equal to 0 not possible because x is cos theta cannot be more than 1 or cannot be less than 1 also, less than minus 1, right. Now, you look at the other expression we have x square plus 2x minus 2 has to be 0, we have a root there, you will get 2 roots here, one root would be minus 1 minus root 3 which is less than minus 1, so you would discard that. The other root is x equal to minus 1 plus root 3, that is going to be the answer there. So, that is the angle at which the disc is going to lose contact. It is a very simple question only, purely at advanced level, not beyond that. Definitely the students are supposed to know it, not just knowing it, doing it very thoroughly and very effortlessly, you should be able to solve that. So with that, I'll conclude here. Thank you very much for your time, and until next time, goodbye.